There y'all are. Oh, we're hiding on me. Actually, I was hiding you on me. And I hit the wrong button again, as always. There we go. I want chat. I want participants. There. If you have not put your name in the chat already, please do so. And what's the other thing I was going to say? Oh, pin my screen. And if you can hear my lovely voice, someone talk to me so I can be sure I can hear you when y'all talk. Well, Sebastian, I see you're talking to me, but nothing is coming over the speakers. So, could you try it again?
Can you hear me now? Hello?
It's going to be fun and delightful. Let me see. Try it again.
Well, how about now?
There we go.
Already.
I had it on this set of speakers before and nothing was coming across. And so I switched to another set of speakers and nothing was coming across. So I came back to the original set and lo and behold, I could hear.
All it needs is a good restart.
What?
Like switching it from one to another always fixes it somehow.
Yeah, it's like a restart, yeah. And I walked by the classroom around 1 o'clock, around 2 o'clock on Monday, and it was working for that person. Zoom doesn't like me, I swear to God, it doesn't like me. The Zoom gods hate me. I'm being smitten by the. Yay. Hopefully. What was that saying? Oh God. I hope that isn't something bad that was happening. Okay, according to my PowerPoint, this is where we left off. Is this true? This was the one right before where we established this identity. So had we done this? So what they did here, they did the add formula for sine and the add formula for cosine to get these two entities. Cosine of pi over 2 is 0, so sine theta cosine pi over 2 goes to 0, so all we're left with is the cosine theta of sine of pi over 2, but sine of pi over 2 is 1, so the numerator is just cosine. And the denominator, something similar happens. Cosine of pi over 2 is 0, so cosine theta cosine pi over 2 is 0. So we're just left with minus sine theta sine pi over 2. Well, sine pi over 2 is 1, so we just have minus sine theta. And yeah, so these two went away. So all we're left is these two with the minus sign in the denominator. Well, sine over cosine is cotangent. Cosine over sine is cotangent, and it's going to be negative because of that negative down there. Okay. So now, well, now they're throwing in the inverse trig functions. So this will be interesting. Because with this, I'm supposed to put my mask on. And it muffles what I'm saying, so I tend to want to speak louder. If I just go ahead and write this as sine of cosine inverse of 1/2 times sine of negative 3/5. No, I'm sorry. Sine inverse of 3/5. Since it's sine, if it's plus here, it's going to be plus between the two products. Oh, no, this would be cosine here, right? It's sine cosine of the cosine negative, the inverse cosine of 1/2 times the sine of the sine of the inverse. I mean, sine of the inverse of 3/5. Right? Because sine of alpha plus beta is sine of alpha times cosine of beta plus cosine of alpha times sine of beta. Right? Inverse trig functions give us a theta, give us an angle. Okay. Well, wait a minute. Over here, things work out where this is just cosine of cosine inverse is just the argument in here, which is 1/2 times sine of sine inverse is just the argument in here, which is 3/5. Cosine inverse of 1/2. I'm wondering how they're going to do it, because I know cosine, the angle that gives me the cosine of 1/2 is pi over 3. And sine of pi over 3 is the square root of 2. I mean, square root of 3 over 2. And this here gives me an angle, and so we're gonna explore that angle. Okay, it's a positive 3/5. So I don't know what quadrant that's gonna be in. So sine is opposite over hypotenuse. So 25 minus 9 square rooted is 4. And so, and this is our angle here, beta. So sine of beta is 3/5. And so whatever beta, so I'm now going to say sine inverse of 3/5 equals beta. And now cosine of beta, because that's what this is now, this is the cosine of beta. Well, I have this triangle here, and cosine is adjacent side over the hypotenuse, so 4/5. So this becomes the square root of 3/2 times 4/5 plus, I'm going to go ahead and multiply here and say this is 3/10, and this is 4 square roots of 3/10 plus 3/10, which is 4 square roots of 3 plus 3 divided by 10. I'll write this over here. 4 square roots of 3 plus 3 divided by 10. Did anybody see any mistakes I may have made? Because you know I do it because I get in a hurry and I get all excited and I make mistakes. Because I'm in just such a hellfire hurry to get to the end that. Oh. Don't leave until you sign. Okay. So I'm gonna worry about pulling that out at the end of class. Okay. So I don't think I made any mistakes. See, and I could have done this the same way. Where this would be the sine of beta. And the sine of beta, right? Because the sine, I said the sine of this, the inverse sine of 3/5 is beta, and the sine of beta is 3/5, so that was right. And I could have done something similar with the 1/2 and made another triangle. As a matter of fact, that's probably what they do. And we're going to call this alpha here. So cosine is adjacent over hypotenuse. So 4 minus 1 square rooted, right? The square root of 2 squared minus 1 squared equals the third side. So that's going to be the square root of 3. And then sine of alpha, because this is alpha in here and this is alpha in here. Sine of alpha is the opposite side, which is the square root of 3 divided by 2, which is what we have here. So I covered all my bases. So let's see how they do it. How they do it is sometimes more complicated than it needs to be. Like this wasn't complicated, Mr. Reed. Okay. So alpha is going to be, so well, they went ahead and assigned what alpha and beta were. And then since cosine equals 1/2, so that means it's going to be between 0 and pi. And sine is 3/5, so it's going to be between negative pi over 2 and pi over 2. Well, the point is we're getting positive sine. and we're getting positive cosine. And the only place they're both positive is in the first quadrant, between 0 and pi/2. Okay, they did it this way. Well, no, yeah. So sine of alpha is the square root of 3/4, which is the square root of 3/2. So they did it using the Pythagorean trig identity. And same thing with the cosine of beta. Okay, so they got the same two things for sine of alpha and cosine of beta. As a result, sine of that equals sine plus alpha plus beta. Well, I didn't worry about that. And so getting this, we know and we know what sine of alpha is, and we know what cosine of beta is. We know what cosine of alpha is, and we know what the sine of beta is. And they did the same thing I did. They just went a different pathway. They found these numbers pretty much the same way I did by using the Pythagorean theorem, but they used the Pythagorean identities for the trig functions. Okay. So we're going to write sine inverse u plus sine cosine inverse v as an algebraic expression containing u and v, that is without the trigonomic or frictions, trigonomic functions, and stating the restrictions on u and v. Okay. Oops. All right. So we're going to do something similar, where sine inverse u is alpha, and cosine inverse v is beta. All right. So the restriction on u is from -1 to 1. And with cosine, the restriction again is from -1 to 1, because we can only take sine and cosine inverses of the numbers between -1 and 1. Okay, so those are restrictions on v and u. And then setting alpha being sine inverse. So this is going to be sine of alpha plus cosine plus sine of alpha plus beta is what we're doing. So we can rewrite it this way. And now we know that alpha and beta are going to be restricted. Alpha is going to be restricted between -pi/2 and pi/2, and beta is going to be restricted from 0 to pi. Because we're talking about the inverse, since we're using the inverse functions, we're restricting our domain and range on both functions, the inverse and the trig function. So because alpha has between -pi/2 and pi/2, cosine is going to be positive. And so cosine alpha is going to equal the square root of 1 minus alpha squared. And alpha squared is u squared, because sine of u is alpha. I mean, yeah, sine of A is alpha. Sine of alpha is u. Right? Where did they state that? Oh, here. Right? Because of that's what this means. What angle gives us u? What's that the sine of that angle gives us u? Well, we're going to say this is alpha, so that means the sine of alpha is going to give us u, and the cosine of beta is going to give us v, because the inverse of cosine of v gives us beta. So cosine of beta gives us v. And so that's how we replace things in there. So that's how we know this part here, that cosine A is the square root of 1 minus u squared. And because beta has to be between 0 and pi, that means sine has to be greater than or equal to 0. And so the sine is going to be positive, so that's what they're talking about here, is that cosine has to be positive, so it's a positive square root. Here, sine has to be positive. Since beta is between 0 and pi, and sine is positive between 0 and pi, the first and second quadrants, that's where sine is positive. And so we get that sine of beta is the square root of 1 minus v squared. So now this equals we're going to replace sine inverse of sine inverse of u and cosine inverse of v with alpha and beta, because we stated that's what they are. And then we can write out the function. It's this the sine of a sum. So you're going to add the two products, and the first one is going to be sine alpha times cosine beta plus cosine alpha times sine beta. And I know sine alpha is this lovely thing, and cosine beta, what is cosine beta is u. And cosine alpha, no, this is u. This is u, and this is v. And this is the square root of 1 minus v, and this is the square root of 1 minus u. Yeah. So we have u times v, uv, plus the square root of 1 minus u squared times the square root of 1 minus v squared. And this you can write as a single square root, but do that. Do they do that? No, they leave it this way. Because you can write this as a single square root with 1 minus u squared inside parentheses and 1 minus v squared inside parentheses, and it's going to be 1 square root of that. And if you wanted to multiply it out, it's fine. Leaving it this way is fine. But there we have that expression as that trigonometric expression as a algebraic expression. Now we have sine plus cosine equals 1. And we're talking between 0 and 2 pi. So that's the whole circle. Just the degrees less than the positive degrees less than 360. Okay. Square both sides. So I'm gonna square sine plus cosine. Like that doesn't mean it becomes sine squared plus cosine squared, because I'm squaring a binomial. And when you square a binomial, you get a middle term. I square the sine, I square the cosine, and the middle term is multiplying the two together and doubling it. Now I know sine squared plus cosine squared is 1. So 2 sine cosine will equal 0. Right? Because when I add these two, I get 1. And subtracting 1 from both sides gives me 0 on this side. Oh, man. Oh, man. Is this gonna work? So sine times cosine equals 0. Oh, so you get 2 solutions. You get 2 solutions. Divide through by sine. I mean, I have a product that equals 0. So sine of theta equals 0, or cosine of theta equals 0. This is like x times y equals 0. So one of those has to be 0. Well, when sine is 0, that means sine is 0 degrees. So that means theta is 0 degrees. Wait a minute. Or pi. So sine is 0 at 0 and at pi. That's when sine is 0. And cosine is 0 at pi over 2 and 3 pi over 2. So you get not just 2 answers, you get 4 answers. Because we're talking from 0 to 2 pi, not including 2 pi. Because they're considering 2 pi and 0 to be the same. Because the coordinates of that on the unit circle is the same point. Okay. So we have apparent solutions are, those 4 angles. Because knowing your unit circle is very important, because it helps you in things like this. You get the answers real quick. Okay. Because both sides of the original equation were squared, these apparent solutions must be checked to see if they are extraneous. Yeah, we have to check our answers, because we squared things, so that means some of these may not work. So we're going to look at sine of theta plus cosine of theta. And we want the ones that give us 1. Well, when theta is 0, sine of theta is 0, and cosine of theta is 1. This is when theta equals 0. When theta equals pi over 2, because I'm going to go in order around the circle. Sine is 1 and cosine is 0. Now when theta equals pi, sine is still 0, but now cosine is -1. This equals 1, this equals 1, this equals -1. So pi of 2, we can't use pi over 2. Because it gives us -1 when we plug it into the original equation. And now for 3 pi over 2, 3 pi over 2, cosine is 0 again. But the sine is -1, right? Because we're talking about the quadrantial angles. Right? Where this is 0, 1, this is 1, 0. This is 0, -1, and this is -1, 0, sorry. And this one is 0, -1. And so it's like adding those coordinate numbers together is basically what we're doing here. And only these two give us a +1, where these two give us a -1. So that means pi over 2 and 3/2 pi aren't part of the solution because they don't give us the correct answer. So they call them extraneous solutions because we find them as possible solutions, but because they don't work in the original equation or function, then they're extraneous. And that's what they do here. They do the same thing where when you're adding, yeah, so they kind of did it the same way I did, except I didn't write down sine, cosine all the time. I did this column, I did this column, and this one, I kind of jumped over that. Okay. Oh, it was pi or pi. At pi and 3 pi over 2. We get 0. Okay, so I screwed up there. At pi over 2 it works. At pi it does not. And at 3 pi over 2 it does not. Okay. So our solutions were 0 and pi. Or 0 degrees and 180 degrees. So the solution set is 0 pi over 2. Start with, option 2, you start with the equation, divide both sides by the square root of 2. Why? All right. And now the left side resembles the formula for the sine of the sum of 2 angles. One of which is theta, and the other angle is unknown, and they're going to call it phi. Okay. Which is the square root of 2 over 2. Okay. This seems like a little bit more work than it's worth. And so we see that the cosine of phi equals the square root of 2 over 2. The sine of phi equals the square root of 2 over 2. Therefore, phi is pi over 4. So now we have sine plus theta of sine pi over 4 equals the square root of 2 over 2. So there are two angles where the sine is the square root of 2 over 2. And that's these two angles, pi over 4 and 3 pi over 4. So theta plus pi over 4 is 3/4 pi. And theta plus pi over 4 is pi over 4. So you subtract pi over 4 from both sides of the equation here, and you subtract pi over 4 from both sides of the equation over here. And then you get theta is 0 or theta is pi over 2. And who is going to use this method? Notice I'm not raising my hand. Okay. That just seems, yeah, that works, but it just seems too complicated. And why do we want to make things more complicated? Because sometimes you have to. There's sometimes where you do have to make the problem more complicated so you can simplify it in a different way. And that's one of the magics behind mathematics. You take things apart and put them back together again in new and interesting ways to get a different result, or to get the result you need. Okay. All right, what this tagline here is saying that A could be, if A is 0, then B won't be. And if B is 0, A won't be. Because it says either A doesn't equal 0 or B doesn't equal 0. That means they won't be 0 at the same time. Oh, geez. So dividing both sides of the equations by a squared plus b squared. Now, would you think of doing this? I don't think I would. Unless I started playing with it more severely. So now we have this little monster. And now we can talk about, what can we talk about? And so that means there is a unique angle phi for which cosine of phi equals alpha a over the square root of 2 plus a squared plus b squared, and sine of phi equals b divided by the square root of a squared plus b squared. So now we're going to write it in the form of the sine of the sum of two angles, theta and phi, like the last problem did. And so 10 can be written that way. That equation can be written this way. Because now cosine of phi is what the coefficient of sine theta was, and sine of phi is what this coefficient was. And so now this is just going to be so sine of theta plus phi equals this monster. Right? Now, since C has to be positive, and so that means sine has to be positive, or not understanding this statement. If the absolute value of C greater than the square root of a squared plus b squared, then the sine of the sum is greater than 0, or the sine of the sum is greater than 1, or less than negative. Okay, sine gives you a number between -1 and 1. Well, they're saying that this is gonna be greater than 1, it's gonna be outside, which doesn't happen with sine. Sine gives us a number between -1 and 1, and this is saying that sine has to be outside of 1 and -1. So if c is less than 0, less than a squared plus b squared, then the solutions of the equations are well, whoa. Oh, the absolute value, because c could be positive or negative, and this is a positive square root because this is the primary square root, which is positive. And so if it's c is less than or equal to this, then you will have solutions between -1 and 1. And so the inverse sine of c over that is what alpha plus b is. Or alpha plus b equals a negative, alpha minus the inverse sine of this. Because this covers the first quadrant, this covers the second quadrant. Because sine is positive in those two quadrants. So where are they going with this? Once the angle phi is determined by equation 11, the above are the solutions to equation 9. Well, how do we establish the angle phi? What the hell is the point of this? I need to remember to delete those slides for when I teach this class next semester. All right, double angle and half angle formulas. We're going to find out what the double angle formula is. We're going to and to find exact and then use it. And we're going to find out what the half angle angle is and use it. And so we're going to use the double angle to establish identities. Well, these are the double angle theorems. And notice there's 3 of them for cosine. If I take the sine of 2 times theta, then it's the same as 2 times the sine of theta times the cosine of theta. An example, 60 degrees, which is 2 times 30. I think it's easier to see once you explain it using examples. So sine of pi over 3 is going to be the sine of 2 times the pi over 6. Double angle. I double this angle, I get this angle. Using that formula, it's saying it's going to be 2 times the sine of pi over 6 times the cosine of pi over 6. Well, sine of pi over 6 is 1/2. The cosine of pi over 6 is the square root of 3 over 2. And we're multiplying by 2. 2 times 1/2 is 1. 1 times the square root of 3 over 2 is the square root of 3 over 2, which is the sine of pi over 3. So this helps, this doesn't verify it, but it helps understand what's going on there. Well, let's do this on the same angle. Cosine of pi over 3 is the same as the cosine of 2 times the pi over 6. So we're gonna do cosine squared of pi over 6 minus sine squared of pi over 6. Right? Pi over cosine of pi over 6 is 3/2. I mean, square root of 3 over 2. So we're going to square the square root of 3 over 2. And we're going to subtract sine squared of pi over 6. Well, the sine of pi over 6 is 1/2. So we're going to subtract 1/2 squared. When I square a fraction, I'm squaring both the numerator and denominator. So the square root of 3 being squared is just 3. And squaring 2 is 4. So that's 3/4. Minus, well, 1/2 squared is 1/4. 3/4 minus 1/4 is 2/4, which is 1/2. Where the cosine of pi over 3 is 1/2. Using this one. So 1 minus 2 times the sine squared of theta. So that's just substituting 1 minus sine squared for cosine squared, and then subtracting another sign away, you get this one. So this one is a direct result of this one by using a trig identity, a Pythagorean identity, to replace cosine squared with 1 minus sine squared. But sine of, okay, so we're gonna, and it's gonna be, since theta in this case is pi over 6, and pi over 6 is 2, so this is 1 minus 2 times 1/2 being squared, which is 1 minus 2 times 1/4, which is 1 minus 1/2, which is 1/2. Okay, these have to agree, and they do. And that's what the cosine of pi over 3 is. And this last one, so it's going to be 2 times the cosine of pi over 6 minus 1. Well, the cosine of pi over 6 is 3 square root of 3 over 2. So this becomes 2 times the square root of 3 over 2 being squared minus 1. So this becomes 2 times 3/4 minus 1. Yeah, because the square root of 3 over 2 is being squared is 3/4. And 2 times 3/4 is 3/2. 3/2 minus 1 is 1/2. Because that's 3/2 minus 2/2. And 3 minus 2 is 1. So we have 1/2. And again, it agrees. So this one is found by replacing sine squared with 1 minus cosine squared. So we're going to have minus a minus, which becomes minus cosine squared, which becomes plus cosine squared. So we have 2 cosine squared minus 1. I just like showing that because sometimes it makes it a different because I can do different things with these than with these. Having a single angle in there makes it a little simpler, because if it's part of a bigger expression, then something could happen that I can start using trig identities to get me to someplace else. So sine equals 5/6. And so sine is an angle between the square root of 2, pi/2 and pi. So that's the first and second quadrant. And so they established a triangle here so they can do stuff with it. Well, 36, what's 36 minus 25? Isn't that 11? So that's gonna be the square root of 11. So this side is square root of 11, and since it's in the second quadrant, it's gonna be negative, because now the cosine is gonna be negative. So this is gonna, I can rewrite this as the sine. Let me recall that formula real quick. Yeah, I forgot the 2. 2 times the sine of theta times the cosine of theta. Well, I know the sine of theta is 5/6. And from what we got over here, the cosine of theta is going to be negative square root of 11/6. The negative square root of 11/6. And right away, I'm gonna say this 2 goes to 1 and this 6 goes to 3. Because if I simplify before I do any multiplying, it gives me smaller numbers. And so my numerator is the negative 5 square roots of 11 divided by 18. So that's what it equals exactly. And the cosine, I'm going to use the first one, which is cosine squared minus sine squared, right? Cosine squared minus sine squared. So cosine is a negative 11 square root of 11/6 squared plus 5/6 squared. So my both denominators are 36. Negative square root of 11 squared is positive 11. And 5 being squared is, was it plus? No, it's minus, right? Yeah, it's minus. Minus 25, which is what, 14? A negative 14/36, which reduces to a negative 7/18. Now I could have done the same thing by building another triangle. 18 is this side, and if this is the angle we're talking about, then this is going to be 5 square root of 11, and it's going to be, this one's negative. And so when I square this, I get, ooh. Now I don't want to do that, because then you get really big numbers. It's just easier to do it that way. So, yeah. So we have negative 5 square roots 11/18, And we have a -7 square roots of 18. Because when I double this angle, I don't wind up down here. Or even over here somewhere. Well, actually, I'll wind up over here, where the x is positive and the y is negative. Okay. So R is 6, B is 5, so so A is the negative square root of 11. So let me finish that. Which means the cosine of theta is the negative square root of 11 over 6. And the double angle formula. So yeah, they're doing the same thing I am. And they got the same number right. Only, yeah. Oh, okay. So they're just gonna use this one, where I use a different one where I needed to find the cosine of theta. But this way, you don't even need to find cosine, because all you need to know is sine, which is 5 over 6, and 5 over 6 squared is 5 over 36, and 2 times 5 over 36 is 5 over 18. Or 25 over 36, I'm sorry, I forgot to square the 5. And so we get 1 minus 25 over 18. Well, 18 minus 25 is a -7. So that's a -7 over 18, which is what we got. They did it in an easier way, but that means you have to subtract fractions. And I expect my answers to be in fraction form, not decimal form. So that means you can't use calculator to go from here to here. You write this as 18 over 18, and 18 minus 25 is a -7, and the denominator is 18. Ooh. So what's the double angle theorem for 2 pi? I mean, 2, oh. What is tangent in terms of sine and cosine? So that's going to be sine of 2 theta divided by cosine of 2 theta. And which would be easiest? So this is going to be 2 times cosine, 2 times sine theta cosine theta. And we got 3 choices to make for the denominator. I'm wondering what choice they're making. Whoops. Oh, they went a different route, which makes sense. So this is tangent of theta plus theta. So this is going to be the tangent. Oh, what's that formula for the sum? So this is going to be, and I'm not even gonna use this, I'm gonna say theta and theta. Because we want it in terms of theta, not alpha and beta. Okay, and then let alpha and beta, okay, so they're gonna use the same thing. So my numerator, I have tangent of theta plus tangent of theta divided by 1 minus the tangent of theta times the tangent of theta, which is 2 times the tangent theta divided by 1 minus tangent squared of theta. So let's see if they do the same thing I did. And so now they're just going to replace alpha with beta and beta with theta. Because what they have here underneath what I wrote is the same thing, except I'm using theta and theta instead of alpha and beta. But this is going to become what I just wrote there. And so you get the same thing I did. I didn't see the need of doing this. The sum, the tangent of a sum is the tangent, the sum of the tangent of the two angles divided by 1 minus the product of the tangents of the two angles. And it just so happens those two angles are the same angle. Well, you know. Now we have find the formula for the sine of. So, yeah, and that's what I would have done, right? I'm sure you would have done the same thing. And so we're going to do the sine of 2 theta plus theta, which is sine of 2 theta times cosine theta, and cosine of 2 theta times sine of theta. All right, now I can write this as 2 times sine cosine. And I can write this at, well, let's see what they write it as. Use the double angle theorem. Oh, they did cosine squared minus sine squared. Well, I got only those. And so now we have 2 sine times cosine squared. And we get cosine squared times sine minus sine to the 3rd power. Okay. Now, each thing there has sine in it. So I can factor sine out of it. Ba-doom. Whoa. And how'd they get this? Oh, these are the same. So we can write it this way, 3 times, all right, because here I have 2 of them, and here I have 1 of them, so I get 3 sine theta cosine theta minus sine squared sine cubed theta. So there we have a formula for triple angles, which is not what is not considered a basic trig identity. Now, will you have to memorize all these trig identities? I am not that cruel. I will give you a sheet of all the trig identities I expect you to, that you could possibly use. There's some you won't use and some could use, but might not, you'll use something else instead. So, yeah. But you get the idea. So you don't have to memorize all these formulas. The reason I'm remembering them all is because I've been teaching this for 13 years. So, well, actually longer than that, because I taught pre-calculus in high school when I taught high school, so. Some of these I know and some of them I don't. Here is more formulas. I can rewrite sine squared as 1 minus cosine of 2 theta over 2. I can rewrite cosine squared theta as 1 plus cosine 2 theta over 2. And I can rewrite tangent squared as 1 minus cosine, right? All right. See, because tangent is sine over cosine, so that would be this over this. And the 2's would go to 1, the denominators would go to 1, and you'd be left with this. Cool, eh? So write an expression for cosine to the 4th that does not involve any powers of sine or cosine greater than 1. Okay, so right away I can write this as cosine squared theta times cosine squared theta. Cosine squared theta is it plus? 1 plus 2 cosine? No, 1 plus cosine 2 theta. We just had that, right? That was just on the previous slide, right? All right, cosine is 1 plus. Divide by 2 times 1 plus cosine 2 theta, divide by 2. Now, cosine, let's see what they do, because they could, yeah, we're going to use that formula twice. Oh, I see what they did. I see what they did. I'm gonna back up a second. No, what did they do? Oh, they multiplied it out. And just brought the numerator out as 1/4 times. Because this is going to be 1 plus 2 cosine 2 theta plus cosine squared 2 theta divided by 4. Right? I'm going to square the numerator. So that's going to be the binomial 1 plus cosine 2 theta times 1 plus cosine 2 theta, which gives us this. And squaring the denominator, so that's why they pulled out 1/4 out in the front, and so that's going to be 1 plus 2 cosine 2 theta plus cosine squared 2 theta. Well, now we're going to rewrite cosine 2 theta. Cosine squared of 2 theta, we're going to use this same formula again. So this becomes 1/4 times 1 plus 2 times, oh, that's cosine, 2 theta plus 1 plus cosine 4 theta, because I double this again. divided by 2. And what do they do there to rewrite that? They just went ahead and multiplied in by 1/4. And so 1/4 times 1 is 1/4. 1/4 times 2 cosine 2 theta is 1/2 cosine 2 theta. And 1/4 times this. That should have been 1/8. I'm thinking this should have been 1/8. Yeah, that should be 1/8. Another typo on their part. Oh, no. I see what they did. Right here, they multiplied in by 1/4 and got this. And then they converted this. Okay, so now it's gonna be 1/4 times that. So now I have 1/4 here. And 1/8 here, and 1/4 plus 1/4 is gonna give me 1/2. And so well, I factored out the 1/8. Why? Oh, yeah, that would be 1/8. I forgot that I'm multiplying by 2. Are they gonna factor out 1/8? If they factor out 1/8, then this would be 1/8 times 2 times. That would be 2 plus 4 cosine 2 theta plus 1 plus cosine 4 theta. They didn't factor out the 1/8. They multiplied in by the 1/8, which I would leave it there to begin with. And so they added 1/8 to 1/4, which gave us 3/8 plus 1/2 cosine 2 theta plus 1/8 cosine. And I would just like to write this thing as one fraction with 8 in the denominator. So it would be 3 plus 4 cosine 2 theta plus cosine 4 theta, all divided by 8. Which is because this would be 1/2 plus 1/2 cosine and 1/4 times those. And then the 1/2 plus 1 is 3/2, and multiplying everything by 1/4 gives us the same thing I have there. Okay. If you get a question like this on an exam, as long as you get it down to where all of the terms are in, like they only wanted it in, where sine or cosine is in the first degree. So you don't have any of the squares anymore. I solved that. The left side of the equation, except for the factor of 2, is the double angle formula. So if you multiply both sides by 2, you're not going to change your solution, you're just going to change what the equation looks like, so you can use the double angle formula. So 2 sine theta cosine theta equals a negative 1/2. So that means the sine of 2 theta equals negative 1/2. So what angle whose sine is 1/2? Well, there's 2 angles whose sine is 1/2. That's in the third and fourth quadrant. They had no, the only restrictions is that it's going to be within the unit circle. And so the argument is 2 pi. If solutions of this equation, list those in the arrow. Okay. So 11 pi over 6 equals sine of that equals negative 1/2. And the sine of, there's another one. So 2 theta would be 11 pi over 6. So pi would be 11 pi over 12. Or plus pi. So that's going to be 11 pi over 12, which is in the second quadrant, but sine is positive there. Well, it doesn't matter. And then if I add pi to it, or negative pi. Anyway, you get the same angle. Negative pi over 12 is the same as 23 pi over 12, which is pi plus 11 pi over 12. All right. So there you have it between 0 and 2 pi. Pi of 0 and pi of 1. All right. So these two here are not between 0 and 2 pi. So it has to be these two angles. But 2 times this angle additionally, sine of 7 pi over 6 equals a negative 1/2 for any integer k. Except they don't have the k in here. And so we get a bunch of angles there as well that we can look at. So sine is negative in the first quadrant. I mean the third quadrant and fourth quadrant. And so you look at those two angles that give you negative 1/2, and you look at all the iterations of those angles within the unit circle. This one is not between 0 and 2 pi, I mean, and this one is not between 0 and 2 pi. So we're looking at these two angles. So we basically have 4 angles to look at. So those four angles would give us -1 as their sine of 2 pi. Because if I multiply this by 2, I get 7 pi over 6. I multiply this by 2, I get 11 pi over 6. I multiply this by 2, I get 19 pi over 6. I multiply this by 2, and I get 23 pi over 6. Well, those are still solutions to our equation. I will not give you this type of problem. An object is propelled upward at an angle theta to the horizontal with an initial velocity of v sub 0. Usually when we're talking velocity, we use the variable v. This is straight out of physics. V sub 0 is always the initial velocity. So whatever it comes out of the muzzle of the cannon in this case, that is v sub 0. That's its initial speed. Is how fast is it coming out of here. If air resistance is ignored, then the range is the horizontal distance the object travels. And it's given by this formula. All right. 1/16 is the gravitational constant squared. Yeah. Or that's the gravitational constant. If this is in feet, yeah, since this is in feet, that's going, you're being pulled towards the ground at 32 feet per second per second. Oh, this is easy. Because for this to be the double sine angle, sine of a double angle, all I need is a 2 out here. So if I make this be 2/32, then this becomes 1/16 times, 1/32 times v squared times 2 times this, which is sine of 2 theta. So that's just manipulating the fraction so I can get a 2 as a coefficient of this thing. Where did I put it? What did I do? Eat it? I stick it in my pocket. I drop it on the floor. I'm looking for my pen. I can't find my pen. What? Black one. Okay. So I'm gonna 2 times 2/32 is the same as 1/16 times v sub 0 squared, v sub naught squared, sine theta cosine theta. Well, I can rewrite this by factoring the 2 away from the 1/32, and this would be v sub naught squared times 2 sine theta cosine theta. 2 cosine theta sine theta is the sine of 2 theta. And there we have it. Oh man. Find the angle for which R is maximized. Is a maximum. If you don't care about air resistance, then the halfway point here is where it gets maximized. Oh, where R is max. So how far do we get out here? Okay. Okay. So I was looking at it, I was seeing the question different than it was asking. So. Well, yeah, okay. We're always multiplying by 1, so 2/2. And 2, and so they just multiply these two denominators together to get 1/32. And then 2 sine theta, cosine theta, sine of 2 theta. They did the same thing I did, except they did it a little different. And in this form, the largest value for the range of R can be found for fixed initial speed v sub naught. The angle inclination to the horizontal determines the value of R. The largest value for sine function is 1, which occurs when the argument is 2 theta. So when this 2 theta is 90 degrees, then this is 1. Because that's the maximum of the y of sine. So that means theta has to be half of 90, which is 45. Yeah. Without any air resistance, wind, or anything affecting the projectile, you get the furthest distance when the angle is 45 degrees. Now, if you have wind, well, even if you don't have any wind, your furthest distance will be obtained by at a 45-degree angle. But if you have wind, then that affects how far it goes. If the wind is blowing, if it's going against the wind in any shape or form, then that distance is shortened. If the wind is going in the same direction or almost the same direction, then that distance is greater. So, and there are formulas that that take into that account. Which is something that people who were snipers or even hunters need to take into account. Because when you shoot a bullet, even from a high velocity rifle, it doesn't travel in a straight line. It has parabolic shape. And that parabolic shape is deformed by air resistance and wind. And the wind can either increase the air resistance or decrease the air resistance, but you're still going to have air resistance. So after a certain point, even with the highest velocity rifle, there is some degradation off of the vertical, but you really can't tell it until it gets to a certain point. And if the air conditions are perfect, then that horizontal distance is greater. that it follows almost a straight line. The inclination to the horizon at 45 degrees will result in maximum range, pi over 4. Okay. So here we have more, we already have those formulas, but they're reestablishing them because they're going to ask you to use them. Here's our half angle formulas. What were these? The squares? Okay. The half angle formulas. The plus or minus sign is determined by the quadrantial angle pi over 2. I mean alpha over 2. So wherever alpha over 2, which quadrant it puts you in determines whether it's going to be plus or minus. If we're talking first or second quadrant here for cosine, then it's going to be positive. If we're talking third and fourth quadrant, then cosine is going to be negative. So that's what they're talking about there. Yeah. In a different class, they will have you derive these, but in pre-calculus, we do not derive these. That's more like for an upper level calculus class or something like that. And yes, I took a course where we had to derive these angles. And I don't remember it at all. It's been so long ago. A lot of the classes I took, I don't remember anything from. I took 2 classes in theoretical statistics, which is why I hate stats. Because I learned about the theory behind it. Did you know that you can prove likelihood? Anyway, I'm rambling now. We're at time or close enough to it. If you have questions for me, hang around. If you don't, you may leave. And I'm finishing off my cold stale coffee right now. God, that's nasty. Okay.
Yeah, I don't like, when it gets cold.
And then the grip.
Yeah, I like iced coffee, but it's different when it goes from hot coffee to cold coffee. It tastes disgusting.
Well, once it reaches a certain temperature, you dump ice into it. Yeah. Bye-bye. Oh, I need to get you the sign-in sheet so you can sign it. Uh-oh. Oh, this is nice. I got a phone call after class. Said it during. Hello.
Hi, this is Aaron. Thanks for being a CPS Energy customer.
I am not a CPS Energy customer, so go away. Fuck you. Actually, the condo I live in is a customer, but I pay my bills through my home.
You live in a condo?
Yeah, we were fortunate in that the house we had been living in, we sold the house. And we got enough money out of it that we could buy the condo outright. So we don't have any. Well, you were online on that day.
Yeah.
So don't worry about it. Wow. None of my in-class people were here today. Not a one of them. All right, my in-class people, why are you coming to class? Come on. I know it's not my breath because I hide it behind a mask.
See you Monday.
All right, you take care.
You too.
All right, I gotta close down the PowerPoint, click and it goes away. Close that down. And then I close this window. Close this window. And this window. And this window. All right, I'm shutting down Zoom. So now's your last chance to talk to me before I go bye-bye. And now I go bye-bye.